Interval notation. Interval notation is a type of notation that can be used to describe the solution set of an inequality. Interval notation is like the starting point and the stopping point of a graph. Remember, a graph gives the picture of the solution set for an inequality. So the interval notation will describe this graph, this picture of the solution set. So it will have a starting point, a comma, and a stopping point. The first thing you'll need to do before you can do interval notation is to draw the graph or work from a graph. And to get our starting point and stopping point, we're going to use parentheses or brackets just like the graph. Remember, these are determined by the inequality symbols. So if you have greater than or less than, these are going to be parentheses. And if you have an equals underneath, these are going to be brackets. And we will use the same on our interval notation for our starting point and stopping point. If the shaded area of the graph extends forever, we will need to use the infinity symbol. The infinity symbol in the interval notation always gets parentheses because you are never able to touch it. Our infinity symbol, if the graph goes forever to the right, it's like a sideways 8, and then it will get the parentheses. If it comes from the left, so it goes forever to the left, it will be a negative infinity, and it will have the parentheses. Let's write the interval notation for the double inequality that's graphed here. So we're going to have a starting point and a stopping point of the graph. We're describing this graph because that's the solution set. The starting point, or the leftmost point, is -1, and it gets a bracket, so ours should get the same. Then a comma. Your rightmost point of the graph is the 3, and it gets a parentheses, so your interval notation will get the same. Let's write the interval notation for a graph that extends forever in one direction. So remember, this one's going to use an infinity symbol. We want a starting point, a comma, and a stopping point. Well, this graph, we're starting from the left, and it's actually going forever in that direction. So we're never able to touch anything on the left. So this one is going to come from negative infinity. The stopping point, or the rightmost point on the graph, is going to be -1. And our notation will get a parentheses just like the graph. So the -1 is actually not included. So because it's coming from the negative, it's going forever in that direction. It is coming from negative infinity. And the infinities will always get parentheses. You're never able to touch it. We're going to continue, and then we stop at -1. That is the rightmost point of the graph. For this graph, the only difference is we have less than or equal to, and so we have a bracket on the -1. So for our interval notation, starting point, it's coming from the left. We're never able to touch that, so that will be from negative infinity. The stopping point will be the rightmost point, -1, and it's going to get a bracket just like our graph. For the interval notation on this graph, our leftmost, or starting point, is going to be -1. We need a parentheses just like our graph has. So do parentheses, -1, our comma, and this one continues forever to the right. It never stops. So it's going to go toward positive infinity, and that will always get a parentheses. For our last example, x is greater than or equal to -1. Our interval notation, our leftmost point is the -1, and we will need the bracket just like the graph. That's our starting point. This one goes forever to the right, so it never stops. It goes toward positive infinity, and infinity always gets a parentheses. Graphing inequalities. Inequalities, like equations, are statements with expressions on both sides. Inequalities have the greater than, less than, greater than or equal to, and less than or equal to symbols instead of the equal symbol from an equation. Another difference between inequalities and equations is the type of solutions that you get. In both, the variable is isolated, but in inequalities, you get an infinite number of solutions. Equations give us answers like x equals 5, while inequalities give us answers like x is greater than 5. Since the inequality gives us an infinite number of solutions, we often graph the solution set. Let's look at this example. We're going to graph x is less than -2. The first thing you're going to do is find your endpoint. This -2 is going to be your endpoint, so we'll make a mark there. That's our endpoint. Now we're going to shade half of the number line. You're going to shade the part for x, so the part that would make it true. This says x is less than -2. So numbers that are less than -2 are going to be to the left. So we'll shade this half. And then we have to decide about the endpoint, the -2 itself. It depends on our notation whether we want to include it or not. If we have greater than or less than without an equals underneath, we will use a parentheses. We do not want to include it. If we have an equals underneath, we will include it, and we will denote that with a bracket opening in the direction of the shading. So notice on your inequality symbol there is no equals underneath, so we want to use parentheses, and we will open in the direction of the shading, so it needs to go to the left. Let's look at this example. We want to graph x is greater than -2. So we'll find our endpoint, which is -2. Then we're going to shade the half that makes it true. This time it says x is greater, so it's going to be bigger than -2. It will be to the right of -2. So we'll shade that side. And then we decide about the endpoint, the -2 itself. There is no equals underneath, so we do not want to include the -2 in the solution set. That's denoted by a parentheses. It will open in the direction of the shading, so this time it will need to go to the right. This time let's graph x is greater than or equal to 3. So first thing is we need to find the endpoint, which is the 3. We want x to be greater than or equal to the 3. So greater than 3 would be to the right of 3. That's bigger. And then you have to decide for the 3 itself. This time there is an equals underneath. It is greater than or equal to. The equals will cause us to choose a bracket so that we include the endpoint. Now let's graph x is less than or equal to 3. So the first job is still to find the endpoint, which is going to be the 3. And then we want to shade the half that makes it true. So x is less than, the 3, or smaller, so we're going to shade to the left. That would be smaller than the 3. Then we have to decide about the 3 itself. This time we have less than or equal to. The equal to underneath is what causes you to choose a bracket instead of a parentheses. It will open in the direction of your shading. The next one we're going to graph does not have the X on the left. It's a little more awkward to graph because we have to read it from left to right. It says graph 1 is less than or equal to X. So we're still going to first mark the endpoint, which will be 1. And then we're going to shade the half that makes it true. We're going to shade for the X. This says 1 is less than the X. So if 1 is smaller than the X, then the X has to be bigger than 1. We're shading for the X. So we're going to shade to the right. If you have a choice anytime when you're solving, keep the X on the left so the graph will be easy. But if you have to graph one of these, you can. Just be careful, and sometimes you have to re-say it to yourself. So we found the 1, and it says 1 is less than the X. So X had to be bigger than 1. So we shade for the X to the right. Then we'll deal with the equals sign underneath. So it has the equals underneath. That means choose a bracket instead of a parentheses. You're going to include that 1. It needs to open in the direction of your shading. Next, we'll graph for one that has a fraction. We're just going to have to guess at the location of the fraction. So X is less than or equal to 1/2. So 1/2, it's positive, so it's between 0 and 1. So I'm just going to go about halfway, and we'll say that's about 1/2. And we want to shade for X. X is smaller than the 1/2, so it's going to be to the left. And then we do have the equals underneath. So that will be a bracket. It will open in the direction of the shading. And we might mark our fraction on here. We'll say this is 1/2. If your number line is not already written out for you, all you have to really show is your endpoint. You don't have to show the other numbers. In our last example, we're going to graph what's known as a double inequality. Notice it has 2 inequality symbols in it. So it's actually going to have 3 sections in the graph. Your endpoints are the -1 and the 3. So we're going to find those. So our -1 and our 3. And this says X is between those. So we're going to shade in the middle part. The -1 is less than the X, and the X is less than 3. But an easier way is just to say X is between -1 and 3. So it's going to be this middle section. And then you have to choose for your endpoints. For the -1, we do have the equals underneath. So that will be a bracket opening in the direction of your shading. And then for the 3, there is no equals underneath. So that will be a parentheses opening in the direction of your shading. Solving inequalities. Solving inequalities is similar to solving equations. You are going to isolate the variable. We have one special rule for solving inequalities because inequalities have to do with order. When solving inequalities, if you multiply or divide by a negative number, the inequality symbol reverses. So it's going to flip over and go in the other direction. Let's consider the following situation to look at this rule. If we're going to choose the correct symbol, greater than or less than, between 5 and 3, well, 5 is going to be larger, so we would choose the greater than symbol. Now, with these, we could do anything as long as we do it to both sides. We could add, subtract, multiply, or divide as long as we do it to both sides. So let's look at this division part, which is going to cause our symbol to flip. And we'll divide by a negative. We'll just choose a -1 since 1 is not going to change the value. Dividing by 1 would still give us 5 and 3. But putting the negative on there, we'll see what happens with this rule. So we're going to divide by our -1. And then we'll clean up. Now we have a -5 and a -3. So which symbol would be correct? Greater than or less than? The -5 is now smaller with that extra negative on there. So we're going to choose the less than. So dividing by a negative, put an extra negative in there and changed the order. So that is what is behind this rule to flip the symbol over. If you multiply or divide by a negative, it changes the order. When solving inequalities, it is a good idea to choose to keep the variable on the left. Remember, with equations, you can solve with a variable on the left or the right. It helps with the graphing of the solution if you keep it on the left for inequalities. It makes it more natural. And for inequalities, you will be expected to solve, graph, and give interval notation. Let's look at the following example. Solve 3x plus 2 is less than or equal to 14. So we're going to isolate our x on the left-hand side. So we'll go on that side, and first we would take off anything added or subtracted. So we're going to take off the 2. It's added, so we will subtract it from both sides. So we're going to subtract a 2. Clean up. Get 3x is less than or equal to 12. Now we go back on the side with the variable and we're ready to divide. This time we're going to have to divide by a +3. You always divide by the coefficient. And so a +3 is not going to kick in that special rule. It's not going to cause anything to flip over. So we'll divide by 3 on both sides. Clean up. So we have x is less than or equal to 4. So this one is solved. Now we'll graph. So we'll just do a number line graph. We show the endpoint, so we'll show the 4. We're going to shade for the correct side. So we're going to shade for x. X is less than the 4, so it's going to be to the left. And then check your inequality symbol. There is an equals underneath. Remember, that's going to be a bracket in the direction of the shading. Then for our interval notation, we will take it from our graph. Remember, it's a starting and stopping point. This graph comes from the left. It never actually touches the starting point. So it comes from negative infinity, and it's going to stop at 4. That is the rightmost edge of the solution. We will use a bracket which matches our graph. I wanted to solve this one on the same screen so that you can see the difference between the two problems. The only thing that's different is this one has a -3 for the coefficient of the x compared to a +3. So if we're going to solve this problem, we're going to isolate the variable, and we'll go on the left-hand side with the x, and we'll take off the 2. It's added, so we're going to take it away from both sides. Then we'll clean up. We have -3x is less than or equal to 12. Right. Next comes our division step. This time we're required to divide by a -3. So we'll take an extra line so you can see. And this is going to cause the order to change. So our inequality symbol is going to flip over. So we have x is greater than or equal to -4. So it's because we're dividing by a negative coefficient, that is what causes us to flip the symbol and go in the other direction. So we can graph, number line graph, show your endpoint, -4. We're going to shade for the correct half. X is greater than or equal to -4. So greater than will be to the right. Right, there is an equals underneath, so that will be a bracket in the direction of the shading. For your interval notation, your leftmost or starting point will be -4. It will get a bracket just like your graph. And it goes forever to the right, which will be a positive infinity. Remember, infinity always gets a parentheses because you're never able to touch it. Next, we'll look at a double inequality. Double inequalities have two inequality symbols, which will give 3 sections. You should isolate the variable in the middle section. Remember, whatever you do to one section, you must do to all 3 sections. Could kind of think of it like an equation with 3 sides. Here's a double inequality. We're going to solve it, and we will want to isolate the x in the middle section. So that's where we look to decide what to do. So we want to get to the x. First, you would take off anything added or subtracted to the x term. So we need to take off this 1. It's subtracted, so we're going to add it to all 3 sides. So we're going to add it to the -3. When we add it in the middle section, it's going to cancel just like we planned. And we'll add it on the other section. That's what makes it okay to do. You have to do it all the way across. Clean up. So here we have a -2 is less than 2x, which is less than or equal to 4. Now we go back to the middle section to decide for our next step. And we want to isolate x, so we're going to get rid of the 2. The 2 is multiplied, so we're going to divide. And we have to decide if this one is going to flip our symbols. We're going to divide by a +2 because this is a positive coefficient. So nothing is going to flip over. We can go ahead and divide on this line if we like. We're dividing out the 2. So we'll divide by 2 here, here, and here. Then we'll clean up. We get -1 is less than x, which is less than or equal to 2. We have solved this inequality. X is isolated in the middle. So x is between -1 and 2. To draw a graph, we can do a number line graph. We need to show both endpoints. So we need to show the -1 and the 2, and then we shade for the x. A good way to say this is just x is between -1 and 2. So it's going to be your middle section of the graph. So we'll shade in there. Then for the endpoints, for the -1, notice there is no equals underneath the inequality symbol. So you're going to have a parentheses in the direction of your shading. For the other inequality symbol, there is an equals underneath. So this one will get a bracket, and it will also open in the direction of the shading. Now we have the graph. We can do the interval notation. Our starting point or leftmost point is -1. We use a parentheses just like our graph. Our stopping point or rightmost point of the graph is a 2, and it will get a bracket just like our graph. Here's a couple of homework questions from 2.9. So for the first one, you would want to simplify on each side. So on the right hand side, this one will simplify, distribute your 2, and this will give us 10 minus 2x, and take the parentheses off. We can bring down the rest, keeping your symbol, right? Now everything's simplified. We have x on both sides, so we want to get rid of one of those. With inequalities, it's best to keep the x on the left, so we will get rid of the minus 2x. To make it cancel, I need to add 2x to both sides. So I'm going to bring down what I have, and I'm going to add 2x to get rid of that one. Bringing just what I have, and now I'm adding 2x. So my new step on each side was add the 2x. Right? Clean up on the left-hand side. You have like terms, different signs, subtract, sign of the larger. And now it's a standard two-step inequality. Work on the side with your variable and take off your 6. It's added, so we're going to take it away. We'll take it away from both sides. Clean up. On the left, we have negative 2x greater than or equal to 4. Next is your divide step. This is the step where you have to watch whether your inequality symbol is going to flip. If you divide by a negative, it will flip. This one is going to require you to divide by a negative, so I'll take an extra line to show that. So my order is going to change and my inequality symbol will flip. Clean up. You have x is less than or equal to a negative 2. So it's solved. Your graph is just a little number line graph. Show your negative 2. Shade the side that makes it true. X is less than, so it's over to the left. Could be equal to, will be a bracket in the direction of the shading. And now your interval notation. So it's coming from negative infinity, and it's going to stop at negative 2, which will get a bracket just like your number line. Here's another inequality. You would first check for simplifying. So on the left, there's nothing you can do. On the right, you will distribute your 6. So left is going to stay the same. So we'll get 6x on the right plus 18. Parentheses comes off. Now we're going to solve. We do have a variable on both sides. Since it's an inequality, let's keep the variable on the left. So we're going to get rid of the 6x. Positive 6x, so we need to take it away from both sides. Then we'll clean up. On the left-hand side, the like terms go together. Different signs, subtract, sign of the larger. And now you have a two-step inequality. So work on this side with the x, and you'll take off the 2. It's subtracted, so we're going to add 2 to both sides. Clean up. And now we'll go back on this side with the variable. We're ready to divide. We do have to divide by the sign of the coefficient. So we have to divide by a negative. Our inequality symbol is going to change directions. It's going to flip over. So x is greater than a negative 5. So it's solved. We'll do just a little number line graph. Show our endpoint negative 5. X is greater than the negative 5, so we'll shade over here. For the endpoint, there is no equals, so it will be a parentheses in the direction of the shading. And then interval notation. It starts at negative 5 and goes forever to the right. I did use parentheses to match the graph, and both were because there were no equals underneath on the inequality symbol.